complicated. For example, I might need to add a parameter saying that I'm using it to show. In other words, I'm using it from show caseload, or I'm not using it from show caseload. Because if I'm using it from show caseload, maybe there's some additional functionality that's necessary or relevant to the display process. Now, whether or not that makes sense here, the point is that in general, as you make your code more generalized, less specific to one context, it'll often get more complex. You need to ensure, for example, backward compatibility. The way my code worked before, it still needs to work, but that same code is now externalized. Let's take a look in my file. So I take out my show caseload used to call the current caseload logic directly inside of it. Now it's going to call the current caseload function, retrieve that caseload, do some display of the caseload functionality. But now it's also available as a separate function, so I can call it right here. So notice I've removed it as a subprogram from distribute calls. It's no longer here. I've now put it up to the package body level so it can be called by multiple programs in the same package. Okay, so there's an example of a piece of code I recognize that I'd written before that I can generalize and make available and reuse and not copy and paste. In addition, of course, there are other people on my team writing code, and I realized that last week Sally emailed us all with news of her new call util utilities package. And one of the things it offers is returning the average workload of an employee. Fantastic! That's just what I need. So again, I'm not going to create a local subprogram. I'm simply going to call the packaged utility. And this package, with a public program, has the widest scope possible. Any schema with execute authority on this package can use the department average caseload utility. So again, back to my code. It's in here somewhere. Let's see. I do call util department average caseload, and I remove it as a local subprogram. So I still got local subprograms, but they're getting more and more specific. This is stuff that I only use in this context and not elsewhere, and it's not already defined. So then I implement what's left. I move down to the next level of detail. For example, assign next open call. That's a really big, complicated program all by itself. So I repeat the same process. I go into that subprogram. I realize that I need to do several steps. I need to get the next open call, assign that call to the employee, update the information, or add some information into the underlying database. But again, I create a local subprogram to hide the details of how I get to the next open call, so that my executable sections always stay small, very readable, and I only need to go into the next level of detail if necessary. And eventually, as I go through this multiple layers of hiding of details, I get down to the real code. In other words, I deal with actual data structures, whether they be records or collections and so on, and the specific algorithms, but I will not be overwhelmed by the complexity of what I'm dealing with. Now, I've been showing you the local mod step-by-step file, and you should go through that yourself as well. There's also another package I wrote called Top Down to facilitate building code like this. And this will do automatic code refactoring. It will insert stubs into your code. I won't go through all the details here. There's a fair amount of documentation. It also has a program called TBC, to be completed. And one of the things you might do as you're building these kinds of stubs is avoid writing return null, or just null inside your procedures like I did here, because the code will compile, and if you try running it, well, it won't do anything, but it won't give you any errors either. And another approach you can take is to use my local module, or the top-down to be completed. Here's an example. Top-down TBC, to be completed, instead of null. And then, if you try to run this code, it'll actually tell you your code's not completed yet. So let's, in fact, do that. I'm going to show you what this looks like. I'm going to compile this code. Whoops. Let's go over here. I'm going to compile my package. We'll ignore these transient errors. I should have a package valid at the end. And now when I try to run my program, distribute calls, even though it's not finished yet, it's still filled with stubs. Now it gives me an error saying, Stephen, your program named call still unhandled has not yet been implemented. So the top-down package will give you a nice structured way as you're building out your stubs to avoid forgetting that you've implemented something. And instead it will remind you that you still have something to do. It's still to be completed. So that might be useful to you. Let's talk about some of the challenges of working with local modules. First of all, the main thing, it requires discipline. As you find yourself writing more and more code, you should say to yourself, stop, don't do it again, don't get lost in your code. Instead, take out the chunks of code you're writing, put it inside a procedure, refactor your code to make it more understandable. So just build a sense of discipline and allergy to writing these long programs. You change the way that you read your code when you write this kind of approach because you're reading from the bottom up. Let's take a look at an example of that. In my series on dynamic SQL, I talk about a program called Intab, which uses DBMS SQL to perform method for dynamic SQL, a very complex approach. And you might want to check it out. But the main thing here that I wanted to point out is that my program is over 400 lines long. But the main body of code is just 5 lines long. And it literally tells the story. It's like a table of contents. Load the column information, construct and parse the query, define the columns and execute, build and display the output, and then clean up. And with a product like Toad, of course, I have access to my navigator, which shows me all my different programs. I can easily move through them and figure out what's going on. But the point is I go down to the bottom of my program and then read up instead of reading from the top down. So that takes some getting used to, but having a good editor will really make the difference there. Now, I've certainly got complaints about this technique of writing lots of local modules because sometimes people say it can feel like a wild goose chase. I need to fix a bug, so I go to the program, but there's nothing there but other subprograms. I go to those subprograms, there's nothing there but other subprograms. Where is it actually implemented? And I can understand that that can be kind of frustrating. Again, having a product like Toad available will help you understand the structure of your code, even if it's a lot more complicated. Here, for example, is a package that has 4 levels of nesting in one of my subprograms. Load arguments. If I open it up, I can drill down to local subprograms, local subprograms, local subprograms, local subprograms. So here's an example of 4 levels of nesting. And this became, for some people, this would seem like a lot. For me, it was great because what it ended up with was a classic example of hiding underlying code that is so complicated it's hard to understand. My 5th level down, add breakout, consists of one single assignment. That's all it is, one executable statement. But look at that. I'm assigning a record to a 4-level nested collection, one of the most complicated structures I've ever written in PLSQL. But because I took the time to write lots of local subprograms, and I hid everything behind names, whether they're names of procedures or constants, it's very easy for me to understand and explain this code, even years after I wrote it. So it's true, it can sometimes feel like a wild goose chase, but what's the alternative? The alternative is that you end up writing multiple copies of your program, your logic, and then you have to fix them in multiple places. So there's clearly a trade-off here, but I would much rather trade off complexity for simplicity, even if that simplicity means that I have to go through some extra steps to find my code. Another problem with local subprograms is you can't directly test them. This is certainly true. If I declare programs that sit inside other programs, for example, assign next open call, I cannot directly test assign next open call. Heck, even if it's a private subprogram, if it's defined in my package body but not in my package spec, I also can't test it directly. Now, when you've got private subprograms, let's go back up here. Here's an example of a subprogram current caseload, which is currently used by show caseload and distribute calls, but it's not in my package spec. If I do need to test or want to test the function current caseload directly, I can move the header out to the package specification. I don't even have my package bodies here. Here, let's go to this file. So I could always add the current caseload to my package specification if I did want to test it directly. But my local subprograms like assign next open call, not a possibility. You can't directly test this. If you needed to test this program directly, if it was of such complexity that it needed its own testing, then you need to take it out as a local subprogram, move it out to the package body level, expose it in the package specification, and then you can test it directly. So the requirements and the complexity of your code will sometimes lead you to take things out of their local context and make them more accessible at a higher level, even if only to simply test them. And really, that leads us to the last basic question around writing tiny chunks of code. How do you decide when a module should be defined at a local level or at a higher level? And my feeling is you should define subprograms as close as possible to their usage. So when should it be local, private to the package, publicly accessible? Well, take a look at how it's being used. If that subprogram only is needed inside another program, in other words, its logic is so specific that it doesn't make any sense outside of it, then leave it nice and local. Because if you move it out to a higher level, your code gets more complex. You have to do more testing. Your code is more generic. And it's further away from the place that it's being used, which means it's harder for people to understand and find the code. If your subprogram might be or should be used by multiple subprograms in the same package, move it out to the package body. If it's sufficiently generic that other developers will need to use it in other packages, then move it out to the package specification. But if you follow that rule of simply figuring out how it's being used and keep your code as close as possible to that usage, I think you'll find that your code will naturally make sense to people. They'll be able to find what they need to find. And then they'll be able to manage that code more effectively and use it more effectively. To conclude, write tiny little chunks of code, no more than 50 or 60 lines of code, no more than you can fit on a single page or a single screen. Now, the main rationale for that is that at a single glance you can take in all the logic at that level in your algorithm. It certainly can't capture every detail, but sufficient detail to understand that level in your algorithm. And also note that on large screen, on high resolution monitors, you can of course fit way more than 60 lines of code on your screen. Don't use that as an excuse to have longer subprogram executable sections. It's still going to be hard to understand. But if you do follow this advice, keep your programs tiny. Every executable section no more than 50 or 60 lines, preferably more like 20 or 30. Your programs will be transparent. Anybody will be able to look at that program and they will say, ah, I know what this program does. I can literally read it, even though it doesn't have comments. And a nice consequence is that your code will contain many fewer bugs. Because you're focusing on the logical expression of your requirements, not the underlying algorithms and data structures, often the bugs that you would write simply will never happen because they just fall away from the direct expression of your algorithms, of your requirements. The quality of your code instantly transformed. People will be amazed how easy it is to work with your code. You will get lots of kudos and thanks from your code developers. And really, all it takes is discipline. And I put all in double quotes because, of course, discipline can be a hard thing to come by, especially when you're pressured for lots of time. But in this case, you don't need any special tools to do your tiny chunks of code construction, though a top-notch IDE like Toad or SQL Navigator will certainly help. Tools are not required, discipline is required, and the main thing you want to do is watch out for copying and pasting of code. Control-C and Control-V are probably some of the worst things that have ever happened to developers. Thank you, Microsoft. So try to avoid doing that. If you realize you need the same code or similar code in more than one place, then extract it out of both places, generalize it sufficiently so that it can be used by both, and simply put a call to your subprogram in both of those locations. Next steps. We'll download that demo zip file if you haven't already. Unzip it and check out the local module scripts. In this case, I strongly suggest walking through all the different steps in the files, and the local mod step by step really does take you step by step with explanations along the way. And make sure you understand the logic, the idea behind this approach, and that it really makes sense to you, and then try to apply it to one of your own. Pick out an existing complicated program. One of the nice things about this technique is it's good not only for building new programs, but for modifying existing ones. So if there's a subprogram that you find yourself having to maintain a lot, and it's just crazy to understand, open it up, go through the first 25, 30 lines of code, and ask yourself, can I describe that chunk of code with a name? And as soon as you can find a body of code, be it 20 lines or 50 lines, and you can say the name of that code or what it does can be expressed by this statement: process line items, calculate mortgage totals. you can suck out that code from your executable section, put it inside its own local module, drop the code in place, and you're good to go. And in fact, with a product like Toad, you can even do this automatically. I can say, oh, these lines of code, they are calculate mortgage total. So I go to refactor, extract procedure. I can make it a local procedure or a stored procedure. Local procedure, calc totals, press OK, and then my code is moved up to my declaration section. Notice it automatically created parameters for me depending on what was referenced in that block of code, and it replaces it with a call to that program. This is really great stuff, and other tools do it as well, but this is the Toad implementation. It's quite clean and works well. So that's the same technique I showed you manually in an automated fashion. So make sure it all makes sense and apply it to your own coding experience, and believe me, this one tip, write tiny chunks of code, will utterly transform the quality of your code, and you'll find it a sheer pleasure to read your code and to give it to others. So I hope this was useful, and I really hope that you apply this technique and